Hello viewers, welcome to our YouTube channel. In this video, we will solve a problem asked in CSIR NET December 2023. The question ID of this problem is 704100. This problem is related to integral equation and it's a part C question. Question carries 4.75 marks. So we are given a Fredholm integral equation y of x minus 3 integral 0 to 1 tx y of t dt equal to f of x, where f of x is a continuous function defined on the interval 0, 1. Which of the following choices for f of x have the property that the above integral equation admits at least one solution? So we will solve this problem. So the general form of Fredholm integral equation is this one: y of x equal to f of x plus lambda integral a to b k of x comma t y of t dt, and maybe some other function e of x into some h of x may be multiplied here, where this h of x, f of x, k of x comma t are known functions and lambda is the known parameter, and y of x is the unknown function that we need to find. So for this problem, h of x is 1, and so we will convert, or we will write the given integral equation standard form, that is y of x equal to f of x plus 3 times integral 0 to 1 tx y of t dt. So here the kernel k of x comma t is tx or xt. It is same as xt. So it is a separable kernel. So it's a separable kernel. So kernel. So we will see the definition of separable kernel. If k of x comma t can be written as summation I is equal to some 1 to n ai of x into bi of t. So each term will be a product of function of x and function of t. So kernel satisfying this condition is called separable kernel. Our kernel is a separable kernel. So we will solve this. Y of x equal to f of x plus 3 times. So this integration is dependent on t, therefore x is independent of this integration. So therefore we can take this out. Integral 0 to 1 t y of t dt. So this value will be constant. So therefore we can write this as some constant c, where c is equal to integral 0 to 1 t y of t dt. So now we consider this c is equal to 0 to 1 t y of t dt. So from this we can find y of t equal to f of t plus 3t into c, or we can write 3c into t. So substitute this y of t here. You get integral 0 to 1 t times y of t is f of t plus 3ct times dt. So this is c. C is equal to integral 0 to 1 t f of t dt plus integral 0 to 1 3c t square into dt. C equal to integral 0 to 1. So we can keep this as it is, because we don't know f of t, plus 3c. When you integrate t square, you get t cube by 3 0 to 1, so we get c is equal to integral 0 to 1 t f of t dt plus c. So c times 1 minus 0, that is c, therefore we can cancel this c and c. So we get integral 0 to 1 t f of t dt is 0. So therefore we need to find which of the given f of t satisfies this condition. So we are given 4 f of functions. So we have to select which of the given functions satisfies the given equation. Suppose if a function satisfies the given function satisfies this condition, then we can say this integral equation corresponding to this function has at least one solution. So we will take the functions one by one. The first function, let us take f of x equal to x square minus 1 by 2. So option 1, f of x is equal to x square minus 1 by 2. So this gives f of t as t square minus 1 by 2. Let us consider this as equation 1. So equation 1 implies 0 to 1 t f of t is t square minus 1 by 2 to dt. So we are going to find the value of this. So this is equal to integral 0 to 1 t cube minus t square t cube minus t by 2 integral this is dt. Now we will integrate this one. So t power 4 by 4 and this is t square by 2. So we get t square by 4. So when you substitute the limit, we will get 0. So this implies what can we say? This implies f of x equal to x square minus 1 by 2 satisfies 1. So this implies option 1 is correct. So similarly we have to check for the remaining options. Option 2, f of x equal to e power x. So see here, it's e power x. Now the condition is integral 0 to 1. So this is 1. 1 implies t into f of t is e power t dt. So this is equal to integral 0 to 1 t e power t dt. So we can apply the generalized Bernoulli's formula. So generalized Bernoulli's formula. So if u and v are functions of t, then this is equal to u v1 minus u dash v2 plus u double dash v3 minus etc. So this is generalized Bernoulli's formula. So we can apply this where u dash u double dash are derivatives and v1 v2 v3 are integrations of v. So e power t by 1 minus the differentiation of t is 1 into e power t. So the limit is 0 to 1. So we get 1 times e minus 1 times e upper limit minus lower limit as 0 minus e power 0, okay, e power 0. So this one and this get cancelled. So this is equal to 1. So this is not equal to 0. So therefore option 2 is wrong. Similarly, we can check the remaining options. Option 3, Option 3, f of x equal to 2 minus 3x. The condition is integral 0 to 1 t times this f of t. F of t is 2 minus 3t dt. So when you integrate this one, so multiply 2t minus 3t square dt. So when you integrate 2t square by 2 minus 3t cube by 3, so the limit is 0 to 1. So this will be equal to 0. So this implies option 3 is correct. Now regarding option 4, what is f of x? F of x is x minus 1. X minus 1 and integral 0 to 1 t times is f of t is x, sorry, this would be t minus 1 dt. So this is equal to t square minus t, integration 0 to 1 dt. So t cube by 3 minus t square by 2, the limit is 0 to 1. So 1 by 3 minus 1 by 2, so this is not equal to 0. So this implies option 4 is incorrect. So therefore the correct options are option 3 and option 1. So therefore the correct options are option 1 and option 3. So option 2 and option 4 are wrong. So if you like the content of this video, kindly like and share with your friends. Thank you.